Hello, everybody.
Hello.
And welcome to another episode of
The Super Data Brothers Super Show.
That's right. I am Ryan.
And I am Eric.
And we are two real life brothers who work in the data and analytics industry and bring a different level of energy to the intro back and forth. Eric's the chill one. All right, folks. Listen, we have got a great episode today. We've got Roger Whatley and Bill Inmon joining us to talk about their new book, Stone to Silicon or Silicone, I guess, depending on how you want to pronounce it, which is the history of computing and their personal musings on the people that they've known over their careers who helped build the industry we have today. So this is going to be awesome. Keep in mind, everybody, that this is a live show. So you get your questions, comments, reactions into the chat, and Eric and I will read them live on the air and ask Roger and Bill and Patty Haynes, who helped them with the book as well. She's joining us here in a moment. We will get those questions into them. So it's more fun for us. It's more fun for you if you are loud and proud in your participation in the show. So with that said, Eric, anything to share with the people before we read our sponsor?
I think the only thing to share is, get those comments in and we'll read them. We'll discuss it.
All right, cool. So listen, before we bring everybody here onto the stage, we do have to thank our sponsor this week, Good Data. Two papers I want you to check out from Good Data that you are going to find very interesting. The first one is about analytics as code. This covers the transition of business intelligence, really, from more of a click and drag thing to a code-driven thing. This is particularly important for those of you who are trying to use AI to build analytics. The way you're going to do it is with analytics as code, right? The second L in LLM is language. And what are LLMs able to do? They are able to build analytics very easily for you using code. The second one is about the analytics lake. This is kind of an emerging architecture at Good Data that combines the data, the metadata, and the analytics objects into one place, making it easy for humans and AI to find it. Both these papers by Donald Farmer, industry legend. So do check them out. They are great. All right. So with that said, let's bring Roger and Bill onto the show. Guys, welcome to the Super Data Brothers.
Thank you.
To be here.
Yeah, so I loved your book, first of all. Thank you for writing it. I think I can tell you personally, if your goal was to educate people in technology about the history of technology and some of the heroes who built our industry that they might not have heard of, mission accomplished. So I learned a lot from it, and I really appreciate that you guys wrote it. So the first thing I want to start with is really that, like, what inspired you to come together and write this thing to begin with?
Let me go ahead and try to answer that. A while back, a number of years ago, I was at a conference, and at that conference, I was having lunch with several executives from our industry. And at that time, I mentioned that Ed Jordan had died. And I looked around the table, and nobody at the table knew who Ed Jordan was. Then I mentioned the name Gene Amdahl, and they didn't know who he was. And I'll be honest, I was shocked, because Ed Jordan and Gene Amdahl have had a profound influence on the industry that we have, and no one even knew that. Our industry has this strange habit of burying its founders. If you go to, say, medicine, you have Michael DeBakey and Jonas Salk. If you go to the world of physics, you have Einstein and Newton. And in our industry, instead of revering and building on the work that others have done before us, we bury them in an unmarked grave before the body is even cold. And so my own personal inspiration was, our industry has got some really interesting history, and yet nobody talks about it. The venture capitalists and the vendors go out of their way to keep people from understanding what went before. So that was my inspiration. Now, Roger and I have been friends for a long time. even longer before than I wrote the book. So and it's kind of interesting about Roger and I. He and I come from very different backgrounds, and I'll let Roger talk about it. But he and I were friends, and one night we were having dinner and started discussing it, and from there things grew into a book.
That's great. Yeah, Roger, what were you hoping to get out of writing it?
Well, I echo what Bill said. It wasn't something I really had in mind to begin with, but having been in the industry for quite some time, I don't know if you are aware of it, but I have a background not only in hardware design, but also in software engineering and telecommunications and database management, pretty much a lot of the disciplines in the field. But I've always been kind of captivated by the stories behind the technology, the personalities, the quirks, the accidents that changed history. When we talk about computers today, we usually focus on the hardware and the latest software. But for me, the most fascinating part is how we actually got from there to here. I want to chart a course from the beginning, from the people using pebbles and tally sticks to keep records, like I mentioned in the first chapter, all the way to the digital age. And the deeper that I dug, the more I realized how many remarkable individuals, as Bill points out, many of them remain in the shadows, but they were essential to the leaps forward. So I wanted to bring their stories to the foreground to show that the history of technology is as much about human ingenuity and collaboration as it is about machines.
Yeah, while you guys were researching the book and writing it, was there anything that really surprised you or stood out, a connection you didn't expect to find, or a story that you uncovered that you think was particularly noteworthy?
I think the most unusual story that I encountered was how storage came about. In the very early days, we knew we need to have storage. We just didn't know how much. And in the very early days, we did not have engineering equipment to manufacture storage. So one of the very first ways of creating storage was they went to, of all places, Shiprock, New Mexico, and the Navajo Reservation. And in order to explain this, back in that day and age, each byte of data consisted of 8 bits of data. And each bit of data had to have 3 wires, the XYZ wires, strung through them. Well, the people looked around and said, gee, we need people that know how to bead. Where can we find them? And that's why they went to the Navajo Reservation in Shiprock, New Mexico. And the stories of the Navajo women making early forms of storage is absolutely remarkable. Now, today, Shiprock, New Mexico is not a center of high tech, but once upon a time it was. And in fact, if you've ever been to Shiprock, New Mexico, to sit there and even suggest that this is once upon a time one of the meccas of high tech technology, people would think you're crazy, except that it's true.
Yeah, that story really stood out to me for sure. Roger, what about you? Was there anything that really unexpected that you found in writing the book?
Yeah, probably the biggest surprise was how modern old ideas are. Babbage, for example, was talking about modular components and upgrade paths, and Ada Lovelace was describing what we would now call software abstraction. Even the punch card systems of the 1800s look like early programming languages. And then there's the unexpected connections, like how the jacquard loom inspired early computing, or how Cold War missile tracking shaped the first real-time systems. Actually, every chapter had a moment where we said, wait, this is way older than what we thought.
Gotcha. So what do you think drove these early pioneers? What was the motivation when there was like no tech industry, no venture capital, and like not necessarily any promise of a big payday like people nowadays might be looking for?
let me take a swing at that one. I think I know what drove one of our early pioneers, and that was Alan Turing. The story of Alan Turing, I suggest, if you're interested, you read about his life. The remarkable thing about Alan Turing is that he personally saved thousands of people's lives directly and personally, and yet his life was tragic. What Alan Turing did was he was the person that broke the Enigma code in World War II. He and his team of people broke it. He didn't break it individually, but he led the team that did. And the ability to break the Enigma code in World War II saved, in terms of people crossing the Atlantic from the U-boats. Once we had the code broken, we could understand where the U-boats were hiding in the Atlantic Ocean. And in terms of making a transport from the United States to England or the other direction, he saved thousands of lives of people. And so in terms of his motivation, now along the way, he didn't just break the Enigma code, although that was its own major accomplishment. He ideated the whole notion of what a computer ought to look like. Now, in fairness to Alan Turing, he never built a computer. He was the conceptual father of the computer, but he wasn't the actual engineer who built the computer. But in terms of his motivation, he was a patriot and he wanted to save lives. Now, I have to mention his life. And I'm going to say this as honestly and straightforward as I can. He was, if you read a story of his life, you'll find out. He was a homosexual. And in England at the time, it was against the law to be a homosexual. And he struggled with this personally to the point where he finally killed himself. And to think that someone who's had the dramatic and very real positive impact on our life, reaching the point of despair where they killed themselves, I just can't imagine it. But anyway, so what was one of the motivations that led to the computer? One of the most motivations was patriotism and wanting to win the war.
Yeah, you mentioned the Second World War, and that comes up actually quite a bit in the book, I think, where a lot of the foundational technologies were developed to assist in the Second World War. I don't know, Roger, if you could share some of those with us. There's one in particular, and I can't remember what it was, stood out as this huge computer had been developed, I think, to help plot artillery trajectories or something like that. What's the story behind that?
Yeah, actually, the whole thing was pretty transformative, really. Countries needed to crack codes, calculate ballistics, run logistics, really at scales that we had never seen before. World War II compressed really decades of innovation into just a few years. Suddenly, you had unlimited funding from the government. You had all these brilliant mathematicians, and there was the urgency. You had the ENIAC, the Colossus, radar systems. These weren't just academic exercises. They were actually built because the alternative was losing the war. And once the war ended, all that talent and the infrastructure actually flowed into industries and universities. And actually that became the seedbed of modern computing.
I wonder if it's one of the first wars that was won, at least in part, by the contribution of a bunch of nerds.
To me, I think that's the case.
Yeah,
it really was. You take, for example, the human computers. We got the word computing from the people that were doing the computing at that time. A lot of them were women, and they were referred to as computers because that's what they did. They computed the trajectories and they did a lot of the mathematics to calculate ballistics. And from there, when we started building the machines, well, now they were doing the computing instead of the women, so we got the word computers from that. But their contributions are immense. devote part of the, I believe it's the first chapter, to the contributions that women made to the war effort.
Yeah, that's an awesome chapter. I think we have Patty Haynes here in the waiting room. I don't know, Patty, can you hear us?
Yes, I can.
All right, Patty, welcome to the Super Data Brothers show. How are you?
Thank you.
It's nice to have you here. So Roger and Bill have obviously already introduced themselves. Why don't you give us a quick intro?
Oh, a quick intro. I have been involved in technology for longer than I want to even say, but for many, many years. And just all the way from some of our nice, large scientific machines into now lots of work on data and data governance and LLMs and AI and all the different things that have gone from those large mainframes when I started into what we're doing today. So just kind of fantastic to help on this book, because it's just to be able to see all the people that contributed to our technology today. I mean, our little phones that we're carrying around, to see what they were so many, just not even that long ago, is fantastic. So I did truly enjoy being asked advice and looking into some of the technology that was out there during different time periods.
Yeah, it's a great book, Patty. So congratulations on your role in bringing it to life. Before we got a couple questions in the chat, so I'll ask those. But before we do that, I do want to say, listen, folks, the book is available for purchase. So if you go to the link on the screen, you can get your copy of it on Amazon, and it comes, I would say, very highly reviewed. I enjoyed it immensely. I learned a ton. Both the history is great, and then the stories of the people and times that Roger or Bill actually met some of the primary personalities in the book is really what takes it over the top, from being, hey, this is a cool history, to this is really kind of a special book. So check it out at the link you see there. All right, Eric, do you have a question?
Oh, I was going to ask Patty, because we already asked Roger and Bill, but when you were helping with this book, was there anything you learned or found out about that especially surprised you, or you found especially interesting?
There were a couple of things. What I really enjoyed is seeing the size and the weight of those large machines early on, the 40s and the 50s, these huge monsters that were 5 tons. I mean, it was just amazing. And then to look at them and all the cables and everything that was going on to unplug something and plug it back in, to me, just the pictures were awesome, because you could almost feel that 5 tons and think, oh my gosh, this is amazing. The other one that I enjoyed was both Bill and I had the opportunity to meet Grace Hopper. And oh my gosh, I mean, I was in college at the time and didn't really understand how things got started. And yes, I had learned COBOL in college and tried to figure out how to make it all work and make it work efficiently. And then to meet this person who was fantastic, fun to listen to, explain bugs and bits and all sorts of fun things the way she did it, and explained how they didn't have any funding in the Navy for her team to develop COBOL. So they went out and just found like leftover furniture in these government buildings and brought it in for their team. And I mean, she talked about just how they made it work, just because they loved it and they wanted to make it work. So to me, that was exciting to just kind of learn and be able to meet her and listen to that story. So that when writing the book, when Bill and Roger were writing the book, it was fun to be able to just kind of look up those stories even in more detail.
Yeah, it's clear in the stories. One of the big transitions that happens, and maybe we'll talk about this more a little later on. I think there's some more ground setting we want to do, but one of the transitions that happens in the book that's very clear is the early pioneers were doing it out of like a love for what they were doing, right? There was no expectation that, I'm going to create a unicorn and I'm going to own a yacht, right? Like that was not what was driving Grace Hopper in any way.
Yeah, well,
Um,
they definitely weren't chasing stock options like they are today.
right.
I mean, they were chasing ideas, curiosity, mathematics, national survival, and sometimes actually pure stubbornness.
Yeah.
For example, Babbage wanted to eliminate human error. Lovelace wanted to explore the boundaries of logic. The World War II teams were trying to save lives and win a war. I mean, the motivation was pretty philosophical. Can we mechanize thought? Almost universally, it was about pushing boundaries, proving that something that was previously impossible could be done.
Yeah, and we have a couple comments here. So this is Michael Dunphy. Good to see you again, Michael. Michael joins us like every week, so he's one of our regulars. First of all, Michael says it's nice to see Turing getting the recognition he deserved from his contributions to World War II. So a shout out to your comment earlier, Bill, and then a question from Michael. This is deep. So, do you think the progress in compute and AI can be attributed to the increasing uncertainty in the global world? Seems like everything is speeding up for sure. So I'll lob that one over to you three and see who wants to try to tackle that.
Could you go over that again? Is AI doing what?
Yeah, it's just like, do you think that, does the, to paraphrase it, I think, does the increased, the uncertainty in the world today, do you think that is connected to what feels like the increasing speed of progress in technology and AI? Is there a connection there? I think this is a callback to World War II, right? World War II is obviously a time of great uncertainty and also a time of great technological progress. So, are we maybe in a similar situation somewhat today?
We are, and I was about to say that actually we've always been we've always had uncertainty, and it's no different today than it was back then. And the only thing that's changed is the mechanics, how we go about chasing that uncertainty and how we go about solving for it. It's really, to me, there's no difference between now and then.
Yeah. Yeah, that's, go ahead.
I'm sorry. I think some of it also is the fact that with the technology we have today, we are involving worldwide at the same moment a lot of people with their ideas, whereas previously maybe things even took longer. I mean, just to even communicate with another person, if you communicated with a letter or, with a telephone, but now it's just instant. It's somebody has an idea and it's out there being discussed across the world. And now there's opportunities across the world for everyone with their ideas to make money, to improve their lives, to improve the lives of their countrymen. So I really think it's just like technology has almost helped us create more technology faster.
Yeah, that's a good point, Patty. One thing I want to talk about is kind of the evolution of everything. So people tend to think of like they have this idea in their minds that there's the development of the computer, and then suddenly everything was digitized, right? And one of the things you make clear in the book is that this was a very long process, and before there was digital computers, there was like a vacuum tube era, and there was a mechanical era that you talk a lot about with punch cards and mechanical tabulation machines. Can you just kind of give us that story a little bit, and how long this took, and what some of the major stops along the way were?
I can address that. You mentioned in one of your questions about people thinking that there was really a clean break between computers before and computers after, but actually it's a pretty incredibly messy and human, of course. The early computers, as Patty points out, they weren't sleek little boxes. They actually filled rooms and needed teams of people to run them. And the offices had armies of computers, meaning people, figuring out how to translate tasks and data for the machines. Transitioning from paper to automation took decades and involved a much cultural adaptation of technological change. So it wasn't a clean break. For almost a century, we lived in a hybrid world. Mechanical calculators, electromechanical relays, vacuum tubes, punch cards, and of course, human computers. People imagine flipping a switch from no computers to computers, but the reality was thousands of incremental steps. Every new machine still relied on old ideas, and the messy middle is where the magic happens, where humans and machines co-evolve.
Ryan, let me answer your question a little bit differently. Let me talk about the origins of the Hollerith punch card. Now, in today's world, it's been a long time since I've seen a Hollerith punch card, but once upon a time, the Hollerith punch cards were how humans communicated to the computer. And if you're not familiar with a Hollerith punch card, first off, you can find them on the internet. They were an 80-column cardboard card that had little holes punched into it. And these little holes that were punched into it were read by a mechanical reader that translated that into some message to the computer. So that was how at one point in time, humans communicated something to the computer. Where in the world did the Hollerith punch card come from? Well, now the Hollerith punch cards were vintage about 1950 to about probably 1965, sometime in that time frame. What in 1950 did somebody think of that made him think of a Hollerith punch card? Well, you have to look no further than a player piano. Take a look at the insides of a player piano sometime, and what do you find? You find this cardboard roller with holes punched in it, and then you find a mechanical reader that reads those holes and knows what keys to play on the piano. So that's where the Hollerith punch card came from. And then you say, well, where did the player piano get the idea for its occurrence? The player piano first occurred in about 1895. But if you go all the way back to the year 600 AD, you go back to the rug weavers in Persia. If you've ever looked at a Persian rug, Persian rugs are famous for being ornate. They've got everything going. They've got leaves and flowers and diamond designs and borders and trends and yet the rug has got to be woven one single line at a time. How in the world did a rug weaver understand that at this place, on this rug, on this line, it's time to put a blue thread, and then next it's time to put a red thread? How does that figured out? Well, the Persians had an early version of keeping track of what intricately needed to be done on Persian rugs. I think it's interesting. My wife happens to be a collector of Navajo rugs, and we love Navajo rugs, but the ornateness of a Navajo rug is nothing compared to the ornateness of a Persian rug. So you can trace back the origins of the Hollerith punch card all the way back to about the year 600 AD.
Yeah, and the book really starts with the abacus, right? It's when we start talking about the origin of computers and goes from there. I think it's just really fascinating. There's a couple people that you talk about in the book that I think people should hear about, and one of them I'm interested in is Dr. Gene Amdahl. He features pretty prominently in the book, and it's someone I had never heard of before. And I like to think of myself as someone who knows a decent amount about the history of computing, but I had never heard of him. So who was Dr. Gene Amdahl, and what did he contribute to computing?
Well, first off, I had the honor and pleasure of working directly for Dr. Amdahl for 3 years of my life, some of the best years of my life. If it weren't for Gene Amdahl, we wouldn't have, are you ready for this? Microsoft, Oracle, Google, Amazon, none of those people or organizations would ever have existed if it weren't for the profound work that Gene Amdahl did. So let me first talk about what he did, then I'll talk about him as a person. When computers first sprang on the world, when we realized that we could use computers for more than a military presence in the world, all of a sudden there were all kinds of computer manufacturers. There was IBM, Burroughs, Univac, NCR, CDC, Honeywell, TRW, and others. And every manufacturer of computers built their own machine, which then in turn implicated that they had to build their own computer language and data formatting. And so once upon a time, we had all of these different vendors out there, and nobody could talk to anybody else. And even within, for example, the IBM line of products, you couldn't even have the interoperability of data from one IBM type of computer to another. And so Gene Amdahl headed a group of engineers in IBM to solve the problem. What Gene Amdahl did was he allowed for programs and data to be transferred from one computer to the next. And what he did was called the IBM 360 line of computers. And once the IBM 360 line of computers came out, all of a sudden software could be standardized. Not just software, but the transmission of data. Today, if I want to send a file to my friend Patty, I say, Patty, I'm going to send you a PDF. And we think nothing of that. I mean, that's as normal as waking up in the morning. But back in the early days, you couldn't do that. And in terms of writing code, you would write code for CDC, and then if you wanted the same functionality, you'd have to rewrite the code for NCR or Burroughs or somebody else. And so what Dr. Amdahl did was he didn't invent. He was the engineer that created interoperability of data and programs across machines. Something that we take for granted today, something that's one of the foundations of computing today, one of the foundations of computing today. So that's a little bit about what he did. I think the two most important people in the history of computers have been Alan Turing on the conceptual level and Gene Amdahl from the practical level. Those two people had more of an impact than anybody that I'm aware of in our industry. I had the pleasure of working at Amdahl Corporation and Amdahl for 3 years of my life. And I worked on a day-to-day basis with Dr. Amdahl. Now, mind you, I was a very low-level underling. I'm not going to describe what I was doing, but Dr. Amdahl was the chief and I was underling. But what we had was we had these presentations. We had people come in from Indiana and Iowa and New York and Pennsylvania come in to see the new Amdahl machine that was being made there. And so periodically, once or twice a week, we had to go and do presentations to this group of executives. And Dr. Amdahl always started the presentation off, and then he would hand it off to one of the other technicians. And I was one of the other technicians that he handed it off to. Dr. Amdahl was, I'll never forget, in the cafeteria at Amdahl Corporation, you were more than welcome to walk over to his table and ask him about anything. Ask him about the 49ers or the baseball team. He was as open and genuine to talk with as my next door neighbor in Colorado is today. And so he was truly a genius, but talking to him, you'd never know he was a genius. So that's a little bit about what Dr. Amdahl did and the impact he had on our industry and who he was as a person.
I have very little to add to that because Bill did a great job of describing it, but he was actually considered the architect of balance Bill, if you remember his famous law, Amdahl's law, which basically said that you can't just speed up one part of a system and expect miracles. Considered the Yoda of computer architecture. He had a talent for telling IBM what they were doing wrong. Amdahl's law actually basically was that only upgrading your processor was like putting a Ferrari engine in a tricycle. Don't expect miracles.
That's definitely been my experience building a gaming computer all these years later, is you can't expect miracles from upgrading your processor. So Amdahl's law still holds.
Yeah.
Yeah. So on the topic of some of these giants of computing, some of the names we hear a lot are Grace Hopper, and I think a lot of people don't hear as much of is Ed Jordan. But so can you tell us a bit about who Grace Hopper and Ed Jordan are and what they did?
Let me go ahead and start with this. First off, I met Grace Hopper one night. When I met her, I believe she was about 85 or 86 years old. She was really interesting. She was an admiral in the Navy. She was wearing her naval uniform, although she wasn't actively in the Navy at that time. She was about 5'2" and about 90 pounds. And so physically, she was a very slight person. And her military occupational specialty was marine invasions. And so if you can imagine Marines in Tarawa armed with hand grenades and rifles and shooting and bullets going off, this is what she was a specialty at. And so this frail woman invading a beach is something that was ludicrous. However, her beach invasion, she was using her mind. She was a brilliant person, and she didn't invade the beach with her body. She invaded it with her mind. And God thank the Navy for people like that. Ed Jordan was one of the very early pioneers in our industry. Let me take you back to what it was like to be a programmer in 1965, which is what I started my programming career back then. I'm sure most of you weren't even born then, but Bill Inmon put his first code down in 1965. In the days of 1965, they say, here you have a language, here you have a coding pad and a pencil. Start writing code. And there was no discipline whatsoever in the way that you wrote code. None. There was no suggestion that we ought to have modules, that we ought to have callable subroutines. There was none of that. They were saying, start writing code. And Ed Jordan came along and did something called structured programming and design. He was the first person to suggest that there ought to be a methodical way that we produce code and use code. And now he had other contributions as well. He was an author of books. And from a standpoint of his contribution to our industry, he was one of the early founders of the whole notion. I guess you could take it as a very early form of data governance, except that this was the first baby step to what was data governance today. On a personal basis, Ed Jordan was a good and personal friend of mine. He was my mentor. He was my inspiration for becoming a writer. And if it hadn't been for him, I probably never would have ever touched a computer to write anything. He was a quiet person, very intellectual. If I'm not mistaken, he went to MIT, but open-minded and a generous, nice, open person. I knew his wife, Tony, as well. And I will never forget, I was at their house one Thanksgiving, and Tony was making a turkey, except she was taking it to the local shelter. It wasn't for us and her family. So those are some thoughts about Ed Jordan.
That's amazing.
So Bill, another person that has really done a lot of help in that governance world would be John Zachman. And I know you know him also personally?
John Zachman is one of my dearest friends. I claim I've seen more John Zachman presentations than anyone, and that's probably the truth because of the fact that John Zachman and I were at conferences all the time. I must have been to 100 conferences that John Zachman spoke at and I spoke at, and so I've heard John Zachman speak. And I have to say, every time I hear John Zachman speak, it's entertaining. He is the most entertaining and interesting speaker in our industry. John, on a personal basis, is a high integrity person, a very smart person. What did John Zachman do?
Oh.
John Zachman gave us the whole notion of a systematic approach to developing not just programs, but systems. John, you can look up something called the Zachman framework, and you'll find what he did. He likened building a system to the building a house. He said, when you build a house, you got to think about electricity. You've got to think about costs. You've got to think about plumbing. You've got to think about layout. You've got to think about all of these things and put them together. And that's what John Zachman did. John is older than me, although that's kind of hard to believe that anybody's older than me. But John is older than me and has essentially retired from our profession. But John Zachman was a good friend of mine. Still is a good friend of mine. I don't see him as much as I'd like to, but he and I were best friends for 2 or 3 decades.
That's incredible. The Roger, one question maybe you could field for us. So especially the early part of the book, the company that gets mentioned over and over and over is IBM.
Yeah.
And as the book goes along, as each chapter goes along and tells the history of a particular type of technology, at the end of the chapter, those letters disappear. And suddenly we're talking about Apple and Google and Microsoft and that sort of thing. So maybe you could address IBM's place in the history of technology and also take a stab at what happened, because we don't really think of them as at the forefront of technology anymore.
Yeah, that's true. Actually, once upon a time, IBM was the grown-up. They dominated early computing because they had scale, discipline, and of course, huge government contracts. But then the kids in garages, a hobbyist like myself with a soldering iron, circuit boards, we were swapping floppy disk at the Homebrew Computer Club, which I mentioned in the book as well. All of a sudden, tech gets weird, but it also gets wild and personal. Apple made it cool, but Microsoft made it pretty much everywhere. IBM bet on openness and compatibility, but Apple, they bet on design and control. That split actually reshaped the industry and still defines it today.
Yeah, that thread was clear throughout the book. That was kind of the split that happened. You mentioned that, and I'm blanking on the name of it. What was it called? The hobbyist.
The Homebrew Computer Club.
The Homebrew Computer Club. Tell us what that was.
It was actually a group of hobbyists like myself. It was based in Menlo Park. And a bunch of us would get together and pretty much exchange ideas. It was a group of people with circuit board designs. Not that we took our soldering iron with us, but that's what got us there to begin with. As we were developing different ways to use what we called a microprocessor at that time. We still wasn't referred to as a personal computer until IBM came into it, about 1982, I guess. But we would meet and we would exchange ideas. For example, one of the ideas that I had while I was there is there was really no way to print any information from your microprocessor. Again, we referred to them as microprocessors then, to a printer, because there were no printers that had been developed yet for the personal computer. And what I did is I had an electric typewriter. And what I did is I created a circuit board that interfaced with my IMSI computer that I had built to the electric typewriter, and all of a sudden I had a letter quality printer at my disposal. It was those ideas like that we kind of shared with each other.
And there are some big names that attended that. Can you share some of those with us?
Yeah, two big ones that come to mind that everybody can refer to is Jobs and Wozniak. Apple Computer was in its infancy at the time. In fact, it wasn't even around. And Jobs was kind of a different guy. He was more the business kind of person, whereas Wozniak was more like I was. We were the design people. We'd like to really get our hands dirty. Wozniak, we refer to him as the Woz. Wozniak would talk about how to build things, and Jobs would talk about how do we sell things. So that's what I remember about those two. And as it turned out, look what happened with Apple. You know, although Wozniak actually ended up leaving Apple a little bit later after that. He was still involved with them, but not like he was at the very beginning. But those were kind of two notables that I recall. And of course, Osborne with the Osborne computer, he was there also, and a few others.
That how to build things versus how to sell things divide in our industry continues to this day, right? There's two types of people who want to get involved.
Yeah.
And those are the two.
Yeah.
Bill, you do mention at one point in the book that you developed a reputation as being quite a contrarian when it came to whatever IBM's perspective was on the industry. Do you want to address that at all? What was the difference between you and IBM at the time?
Well, this is my perspective, and I know there are other perspectives out there. So I respect the fact that other people think differently. But once upon a time, IBM was computing. There weren't an Apple. There wasn't a Microsoft, and IBM was computing. And they came out with transaction-based databases, which run businesses today in terms of ATM machines, in terms of your airline reservation systems. You find transaction processing machines everywhere. And the thought that I had was that there ought to be different uses of data other than for transaction processing. And this was absolute heresy to the people at IBM, because it was thought that the only use of data was for the purpose of transaction processing. And I came along, I was a writer at the time for a journal called Computer World, and I came along with the suggestion that data could be used for analytical processing. And the people at IBM thought that this was a heresy, that how can you say that? No, you can't use data for analytics. Now, today, we think of that in a different light. We know that we can use data and ought to be using data for analytical processing. But once upon a time, it wasn't so. And at the time, and again, I was writing in public information that was contrary to what IBM was saying. And they didn't like that at all. I'm not going to go into some of the disputes that we had, because quite frankly, some of them were pretty ugly. But IBM thought that they could tell everybody in the world what technology was going to be, and in fact they can't. And I think the best example of IBM trying to dictate technology is a guy named Bill Gates and Microsoft. Bill Gates had a vision that was contrary to IBM's vision, and he did all right himself.
Yeah, he did. He did okay. We have a comment here from Michael. Michael says, all of these stories remind me how we all stand on the shoulders of giants. These personal stories are so interesting. And I agree. Thank you for coming on the show to share them, both of you. Really, this is, and look, Michael, that's what the book's about. So what I would say is get a copy. You can get it at the link here. I'll share it in the chat as well. The Amazon link to buy the book. I highly recommend it. I enormously enjoyed reading it. I think the stories are interesting. The overview of the history of technology is at the right level of detail. You know, it's a quick read, and I just think, you know, all three of you, I mean, again, congratulations on writing it. I think it's a great contribution to the literature we have around the tech industry, and fills a necessary gap, because as we said at the beginning, a lot of people don't know these stories. You know, maybe you've heard of Alan Turing, but have you heard of Ed Jordan? To your point, and I hadn't until I read the book. And the way you lay out Ed Jordan's contribution to the industry makes it clear how important he was in the development of programming in particular. So we just have a few minutes left.
The one thing, if I might interrupt, Ryan,
yeah,
as long as you're talking about the book, is that we should also make it clear that the book really isn't just for techie people.
No,
it's really for anybody that's interested in learning about computers at all, because it's written in very easy, understandable type of way. You know, I think anybody, even without a computer background, would really enjoy it.
Yeah, I agree. That was my experience of it too. You do not need to know what a microprocessor really does going into it to appreciate the history of the microprocessor as presented in this book. So we just have a few minutes left. I did want to kind of talk a little bit about where we are today and where things might be going with you guys. And I'll start that by bringing up this chapter towards the end of the book, about where you introduce this idea of alone togetherness. And that really struck me as something that I've experienced. You know, I have young kids that I think they're going into a world where there's a lot of that. What is alone togetherness, and how do you see that developing going forward?
The alone togetherness concept that I came up with is just from observing people. You know, we're more connected than ever, yet the smartphone era leaves many of us feeling isolated. There's this constant tension. We're surrounded by people, but we're mediated by screens. It affects everything from face-to-face conversation to our sense of identity. Privacy-wise, we're trading more and more of ourselves for convenience, sometimes without even realizing what's at stake. But it's a paradox of modern life. You know, we're constantly connected, but rarely present, is a way of putting it. You know, smartphones gives us an infinite social access, but they fragment our attention. We're together physically, but we're alone mentally. And the design of these systems, you know, notifications, feeds, infinite scrolls, amplifies that tension. We're in a world where you can FaceTime from your pillow, but most of the time you're doom scrolling alone. You know, at Starbucks, next to 10 people, also doom scrolling. We've never been more connected, and yet we're more likely to miss our subway or bus stop because we're busy typing LOL instead of actually laughing.
Mm-hmm. I think that's so true. You can go to a restaurant and see people out on a date or just out having dinner, and they're looking at their phones. And it's like, wait, you went out to enjoy each other, to share stories, to talk, and so many of us are on our phones. And I think younger people are even more comfortable. I'm sorry, Roger, go ahead.
No, I was just going to say one of the schematics that's shown in the book is these 4 teenagers sitting in a booth, and they're both staring at their phones. You know, they're talking to each other, but they're talking to each other through their phones. They're not even making eye contact. Go ahead, Patty.
Yeah, I really, I can tell you as a parent of young kids, I try to keep those things away from my kids as much as possible, to be honest with you. You know, I do see it though in their friends, or when we go out to dinner, and, you know, we live in a pretty small town here in Michigan, and there are definitely families where they show up to the restaurant, they hand the kids the devices,
yeah,
and the kids just spend the whole time on the device, you know, and those are kids who are being raised in this alone togetherness. just 4 minutes left in the interview, and I guess maybe all three of you could take a stab at answering this. I don't know, but really, who should read this book, and what do you hope they take away from it? Patty, why don't you start?
Yes, I would love it if just everybody that has a cell phone reads it, because just to understand, it wasn't just magical that these cell phones came to us and they're so awesome and they do everything for us, but just to understand years and years ago, things happened. As Bill was talking and Roger's talking, all the different folks that were involved in it, and machines, and huge, and now they're just sitting on in your hand. I mean, I just find it amazing. And even if somebody didn't enjoy, connect to one chapter, there's so many ideas in that book that give you where the innovation of people came from. I mean, that's the exciting part, is to see all these people develop so many neat things, and things we needed, with, like Bill talking about Zachman and structure, and even Bill's structure in data warehousing. So anyway, I think it's so much fun to just read a little bit about everything, where you can start to understand how we got to these little phones in our hands.
So who should read the book? I think I kind of alluded to that in the earlier comment that I made, but actually anyone who uses technology, but has never stopped to ask, where did it come from? Or anyone who's curious about where computers came from and where they're taking us. Whether you're an engineer, a business leader, or just someone whose life is shaped by technology, we're hoping that you'll come away with seeing just how human this story really is. Behind every bit and byte, there's stories, struggles, and above all, there's people. And what takeaway? Takeaway simple. Computing isn't magic. It's a human story. And we're all still writing the next chapter.
Yeah. Bill, last words.
Gosh, I think it is an embarrassment that our profession, the IT profession, looks only in one direction, and that we bury our founders, the people that we owe so much to. We don't even remember their names. So I have to admit, my motivation in writing the book was trying, in my own little way, to change the way our industry thinks and works, and start to acknowledge the giants on whose shoulders we all stand today.
Well, there you have it, folks. Stone to Silicon by Bill Inmon and Roger Whatley. Highly recommended by the Super Data Brothers. I really enjoyed the book. And thank you, Roger, Bill, and Patty, for joining us here today.
You're welcome.
Thank you.
All right. So there you have it, folks. What an awesome episode. I could listen to those guys tell stories, I think, forever. And I really did learn a lot from the book, right? Like we all know a few big names in the history of computing. But the thing the book really does an incredible job of highlighting is the heroic efforts of individuals to build this industry. And it's something that, to Bill's point, I think a lot of people don't know. I've told the story on the show before of, I went to Coalesce in New Orleans in 2022, maybe. And I stood at the back of the room as a couple guys introduced the concepts of data warehouses and dimensional modeling to a room full of like 25-year-old DBT data engineers. And they had never heard of it. They had never heard of any of it. No. They were Googling Bill Inmon, and I watched them on their computers, Googling Bill Inmon and Ralph Kimball, and ordering their books on Amazon. And it's clear that they had managed to get a full-time job. They went through school, got a full-time job as a data engineer, and did not know what a data warehouse was.
Yeah, just doing Python and data frames. And
exactly, Python and data frames and that sort of stuff. And so I think this is just a great contribution to that mission, which I support completely, that Bill outlined, which is helping our industry remember its past. So a huge thank you to Roger, Bill, and Patty for writing it. And I think we'll end things there. So we'll be back same time next week, folks, 12 o'clock Eastern, with another episode of Super Data Brothers.
Yep. And then last words, we have a comment on Substack from Corine. Sounds like this book is for everyone, not only techies, and how innovation was because of our shared humanity plus necessities. Thanks.
Absolutely.
All right, well, thank you.
Thank you, Corinne. Yeah, she's a regular too. She watches us on Substack. So, all right, folks,
Yeah.
until next time, I am Ryan.
I am Eric.
And we are the Super Data Brothers. Take care, everybody.
Thank you. Bye.